Okay, good morning. We continue the lesson, but let us refresh your memory by giving you this problem so that you can think a little bit about it yourself. N is a natural number, but I'm assuming natural numbers start from 1. So 1, 2, 3, some number. And then I have I to power of this series. 1 plus 3 plus 5, so the sum of odd numbers up to 2n plus 1. Whatever I give you for n, for example, if I give you n is equal to 10, you put it here, it becomes 21. You start adding the odd numbers from 1 up to 21. That becomes the power for I. I want you to put it in the simplest possible form. Not just for a particular n, for every possible n. Okay? I want to simplify this expression as much as possible. If n is a given natural number, I'm assuming it starts from 1, not 0. Okay? Yeah, please think a little bit about that. And then we continue the lesson by talking about a little bit of new topics today. Okay, any suggestions how to start solving the problem? In principle, this problem shouldn't be a hard problem. If I give you this number, even if this number is very big, it is not disturbing, yes? For example, if I tell you put I to power 1010, yes? In its simplest possible form. Yes? I to power. Is that possible for you to do it immediately, more or less, or not? Let me make it 10,000, yes? Yeah, something like this. I ask you to do this. In principle, it shouldn't be hard for you to do it. Yes? But if you understand the point here, then probably you will understand how to solve the problem. How do you answer this question? Because this number is so big, I have to be concerned. So let me just write I to the power of, we can calculate things in our head, yes? If I ask you to simplify this, how do you simplify this as much as possible? Yes?
You factorize out I, and then you take I to the power 2 to the power 50.
Yes. So then it becomes I to the power of 2 to the power of 50 times I. That is understandable. But I to the power of 2 is negative 1 to the power of 50 times I. And then this becomes what? Positive 1 times I. So this is nothing except I itself. I to the power of 101. But do you think this is the only scenario that can happen? So for example, if I have I to the power of 103 instead, then what I'm supposed to do? The same story, yes? So it becomes I to the power of 2 to the power of what? Can you tell me? 51. But then I have to multiply by I, but then suddenly something changes, yes? Because I2 is still minus 1, that's for sure. But now this time I'm raising it to an odd power, so it becomes negative 1. And then when I get that, it becomes minus I. So, if I give you a particular number, that is extremely simple. You get, I hope that you agree with me, you get how many answers, by the way? How many answers you can get at the end for some power of I? One of them we see is I. One of them we see is minus I. Are these all alternatives, or we have more? In general, for different powers of I. Two of them you see. One possibility is that it's a number so that when you calculate it gives you I. It's a number that when you calculate it gives you minus I. By the way, you see this number is odd. This number is still odd. But the answer to one of them is I. The answer to the other one is minus I. So you cannot categorize the answer based on evenness or oddness. Because these two powers are both odd, but the answers are different. Yes? Okay. Dennis, what do you want to say?
If it's mixed to even power.
How many options are available for the power of I?
I minus I. I don't know. Minus 1.
Minus 1?
1.
1. These are the 4 scenarios going on. Yes? So if I give you I to the power of 1, the simplest scenario is I. If I give you I to power 2, it's minus 1. If I give you I to power 3, it's minus I. If I give you I to power 4, it becomes positive 1. And is that clear? And if I ask you what is I5, I5 is I4 times I. So it repeats itself. Yes? It becomes again I. So there are all alternatives you see. The answer to a power of I is either I or minus I or 1 or minus 1. But it is not, I cannot categorize them based on even and odd. You see, I have even here, the answer is minus 1. I have still even here, but the answer is 1. Here I have odd, the answer is I. Here I have odd, the answer is minus I. So it means evenness or oddness is not a good way to categorize. So then how should I categorize them? Evenness or oddness, of course, play a role. Yes, you see that for even ones, I have real numbers. For odd ones, I have complex numbers. But that is not the whole story. The whole story is the remainder of that power, not by 2, by 4. Because there are 4 alternatives. Yes? So it means that if I give you a number, you have to write this as a power of 4. 2 is working for these simple cases, but it is better to put it as a power of 4 if we can. Yes? Because, for example, here, I to the power of 101, I can write it as I to the power of 4 to the power of 25, and then multiply it by another extra I. Yes? But then you have this list. So the list that you should have in front of you should be this list of 4 alternatives, not 2 alternatives. Yes? And then if I write it as in power of 4, this is always 1. This becomes I. Yes? It's a better option. Because I to the 4 is 1. Yes? Of course, it is not wrong if I give you this in the exam. You can actually solve it in that way, no problems. But it is better to also think about a multiple of 4 rather than a multiple of 2. If you just consider about evenness and oddness, you are thinking about multiple of 2. But now I'm telling you that you can also think about multiple of 4. That's also good. Okay? Okay, how can I answer the question then? I don't know, do you remember? This is an arithmetic sum. Of course, it's a combination of Math 5 problem and Math 4 problem. So that's an arithmetic progression. The first term is 1. And the common difference, D, is 2 units at a time. Okay? And I want to find the sum, Sn. Yes? Is this Sn, by the way, or not? How many terms are there here? Can you tell me? How many terms are there? My question, are there n terms or more in this sum? N plus 1 terms. So this is not Sn, this is Sn plus 1. Yes? Because there are n plus 1 terms. You see, when I get the first term, n is 0. When I get the second term, n is 2. When I get the third term, n is... When I get the first term, n is 0. 0 gives the first term. 1 gives the second term. 2 will give me the third term. So this is n plus 1 terms, not n terms. Yes. So that is Sn plus 1. But what is the formula for Sn? Do you remember? I can tell you. T1 plus Tn divided by 2. But now I have Sn plus 1. So this becomes n plus 1. And then you have the first term plus the last term. And then divided by 2. This is your Sn plus 1. And then if you calculate, it is simple. Why? Because this becomes 2n plus 2. But I can factor a 2 out, so it becomes 2n plus 1. I have another n plus 1 here. And then I have divided by 2. 2 and 2 are gone. So this becomes n plus 1 squared. That's it. So this, I make life simpler for myself by replacing it by a very simple one, n plus 1 to power 2. Is that understandable? So that's a very simple math-wise problem in arithmetic progression. Is that clear? So now I go back and write my question mark. So the question mark is equal to I to that power, to this power, n squared, sorry, n plus 1 squared. So I have to be able to answer this question. So at least I made a little bit of simplification. This is simpler than I had this one. So what can I do? I can raise it to power 2. So it becomes n squared 2n plus 1. Okay, this I can write I to the power of n squared. I to the power of 2n also can be written as I to the power of 2 to the power of n. And then I can write I. First of all, do you agree with what I have written here? Because I am multiplying numbers with the base I, so I have to add the exponents. But this one, 2, will be multiplied by n, will give me 2n, will be added to n squared, will be added to 1, it gives me this. Right or not? Yes? Yes? Okay, but this is already simplified form. I cannot simplify it more than that, but this one, I can replace it with minus 1. So then what happens? Minus 1 multiplied here, it becomes minus. If you don't mind, let me write I first. And then I go here and multiply it by n squared. Yes? The question is that, can I simplify this more or not? Because, for example, you can just say that minus I to the power of n squared plus 1. That's good. It's more simplified than that. It's more compact, yes? But can I simplify this a little bit more or not? So let me not write it to see that if I can get rid of this n squared. Do you think how many options will be available for this? This n that I give you have two alternatives. Either n is even or is odd. Yes? If n is even, then it becomes a multiple of 4. But a multiple of 4 is very easy. Yes? If n is even, for example, say that it is 2k, then it means that n squared becomes 4k squared. This means that I to the power of n squared becomes I to the power of 4k squared, and then it becomes I to the power of 4 to the power of k squared, but I to the power of 4 is 1, so it becomes just 1. So I would say that if n is even, this part is 1, the answer is simply minus I. So the answer to this question mark is minus I if n is even. Yes? And then what happens if n is odd? So if n is odd, then it means that n is 2k plus 1. This is the meaning of being odd. And then what happens? N squared becomes 4k squared plus 4k plus 1. Then it means that I to the power of n squared becomes I to the power of 4k squared plus 4k plus 1. Yes? But then, you see, I can write I to power 4 to power k squared multiplied by I to power 4 to power k multiplied by I to the power of 1. Yes? But I to power 4 is 1. This is also 1, so it becomes I. Yes? But there is another minus I here. Multiplied by that, it becomes 1. So this sum, there is no one particular answer for it. It depends. If I give you an even n, the answer is minus I. If I give you an odd n, the answer is positive 1. Yes? Understandable? Okay, so that's not something that we can answer immediately. Which one? It depends if it is positive or negative. Sorry, if it is even or odd. Okay, so let me just immediately go to the next lesson. So the conjugate, I already talked about that, but not very formally. So the conjugate of a complex number, if I have a plus bi is my complex number z, then you see in the books related to complex numbers, we have this notation and we call it z bar. I put something like a bar on top of z. This is called the conjugate of z, and then you already know what is the conjugate. What is that? A minus b I. That's the conjugate. Conjugate of z. Yes? So what does it mean? It means that you change the sign of the imaginary part to the opposite sign. If it is positive, of course it becomes negative, and if it is negative, it becomes positive. As simple as that, yes? For example, let me write some expressions for you. If I give you z is equal to 2 plus 3i, if I ask you what is z bar, you keep the real part as it is, but you change the sign of the imaginary part to the opposite sign. As simple as that. So it means that this makes a conjugate pattern with that one. That's the reason it's called conjugate. So for example, if I give you z to be 4 minus 2i, then what is z bar? In this case, I keep 4 as it is, then I will change the sign to the opposite, it becomes this. Can you tell me, if I give you z is equal to I, what is z bar? Every complex number has its own conjugate. Yes, it's minus I. Understandable for everyone? Because this is 0 plus 1i. I am not allowed to change the 0 part. I change the 1 to minus 1. So it becomes minus I. Understandable for everyone? So if I give you z is equal to square root of 5, and I ask you what is z bar, what's the answer? What's the answer? The same. Because the imaginary part is 0, if I change the sign of 0, it becomes again 0. So the imaginary part becomes the same number itself. So I can have a lesson here. Z is equal to the square root of 5. Its conjugate is also the same. So if I start with a real number, its conjugate is exactly the same. But what about the other way around? If I give you two complex numbers and I tell you that these are the same, can I conclude z is real? Meaning, is it possible to conclude that the imaginary part is 0? If the imaginary part is 0, z and z bar are the same. But now the question is the other way around. If z and z bar are the same, can I conclude z is real? Yes or no? The answer is yes. Yeah? But why? Because z is a plus bi, I am telling you this is equal to a minus bi. But I told you what is the meaning of equality of complex numbers. It means that the real parts should match, which of course match, and the imaginary parts should match. Yes? But if b is supposed to be equal to minus b, I move it to the other side, positive b, positive 2b equals to 0. So it gives me b is equal to 0. So if it means that the imaginary part of my complex number, which is b, is indeed 0. So this means that there are no imaginary parts, so that is real. Okay, so this is a remark. I want you to write it down. That's important. So I would say that z is equal to z bar if and only if z is real. Okay, so that is very important to know. They are very, very simple, but they become handy, of course, if you want to solve harder problems. Okay. Now there are some properties. The properties that I itemize here are spread around in the problems. Okay. So you can consider them as problem solving, but I will put them under the title of a theorem because for the people who are thinking about understanding things a little bit deeper, these are the important theorems that you can use when you go to complex numbers. So theorem, properties of conjugate. Okay, so, but this is not higher than the level of the book, but they have given these parts as problems in the book. Okay, so let us discover them. I want to show that I am not losing anything. Okay, so the first one is very simple. You can just answer it immediately. What's the answer? Z bar bar. Z. Yes? I change the sign again. I go back to itself. So Z bar is equal to Z. Okay? The second one. The second one is, what can you write in front of this? If I add a number to its conjugate, what will happen? What's the answer? You can imagine these numbers, but of course A and B are not in the problem, so you have to write something independent of A and B. But the way that you have to think is to write something like this in your head. Z plus Z bar, what happens? It becomes 2A, but I cannot write 2A, then people ask what A is. Yes? So what should I write? 2 real part of Z. That's the answer. So all of them they have asked you to do in the book. So if you add Z to Z bar, it becomes 2 real Z. It's a very nice thing, by the way. I can start with a complex number, but when I add it to its conjugate, it becomes a real number. Because real part of Z is always a real number. If I multiply it by 2, it becomes 2. 2 times that, it's a real number. Now, can you answer this question? What happens if I subtract these two? Again, the same idea, but you need to translate it in a nicer language.
Then it becomes 2 imaginary.
What? 2? 2I times imaginary part, not 2 imaginary part. Because if I subtract this and that, so it becomes A plus BI, minus the whole package, so it becomes minus A plus BI. This A and that A are gone, BI becomes 2BI. But I cannot write 2BI here, people will ask what B is. To avoid those, so I would say 2I, but instead of B, what can I write? Imaginary of Z. So it means that the sum is a real number, the subtraction is pure imaginary number. Do you remember that name you need to know? Pure imaginary number means the number whose real part is 0. Okay. Now another interesting thing is this. This is one theorem related to 1Z. But let us make it involved. Let me write it another theorem. Okay, theorem. So let me give you 2 complex numbers, Z and W. Now I tell you that I add these 2 complex numbers, and when I get the result, I conjugate the result. What is the relation between this and the conjugates of each one of them individually? Do you think there is a nice relation among them or no? And if there is, what that is? Is there any relation? So so you shouldn't. It shouldn't be hard for you. You see. So when I am saying that I have two complex numbers, so immediately in your head write a plus bi for one of them. Write c plus di for another one. For example, then calculate z plus w, which becomes a plus c plus b plus di. Yes? And now calculate its conjugate. So can you tell me what is the conjugate of this combination? According to the rule, I have to keep the real part intact. Yes? But I have to change the sign. Yes? But let us continue now. This becomes a plus c. I multiply this minus sign in. And then what happens? I take a with... this is I also. I take a with minus bi. I take c with minus di. But if I ask you what is the name for this, you say that because z was this is just z bar. Yes? So this becomes z bar. And what is this one now? It is w bar. Yes? So it's a nice relation. So it doesn't matter if you add first and then conjugate, or first conjugate and then add. So that's a nice relation, so remember that. Exactly, yes?
When we wrote the conjugate, z plus w,
Bar?
a plus
No,
c
you're right. Thank you very much for correcting me. So this I should be outside.
Okay.
That's what you mean.
Yeah.
That's correct. So, but the calculation was straightforward. So I just picked up two parameters for z and w, a, b, c, and d, and I just calculate z plus w as normal, and then I conjugated it, and then I multiply this in, and then I just group them, and then I realized that this is nothing except z bar, this is nothing except w bar. So if you have a bar on top of the sum, you can break it into two parts. It's not trivial all the time that you can do this. By the way, these operations in mathematics, they are not in general commutable. So it means that the order here, I add first and then conjugate. Here I first conjugate and then add. The result, according to this calculation, is the same. Okay, the same thing happens. I don't want to distract you with the negative sign. You can just work on it yourself. That's also true. But my question is that, is something similar to this is also true for multiplication and division? Because multiplication and division are harder operations. Yes? So my question is that z times w totally bar, is it equal to z bar times w bar? It is not straightforward to answer this immediately. We have to check it. And then my question sum for division is also the same. If I have z over w and I want to bar it, can I bar the numerator and the denominator separately and then divide them? Of course, here I have to assume that w is not 0, otherwise fraction is not defined. So the answer to both questions is a yes. Okay? So I will do the simple one. I will give you the harder one to do later. Okay? So let us calculate, let us convince ourselves that this is indeed true. How should I do that? How should I do that? How should I do this? Number 3. I would say that exactly as before, but the calculation becomes a little bit harder. The reason is the product is a little bit harder operation. So I would say let Z be equal to A plus BI and W be equal to C plus DI, yes? Then what I do, I calculate the left-hand side, I calculate the right-hand side and compare them, for example. That's one way to do it. So, okay, so if I want to calculate the left-hand side, let me just write it like that. Left-hand side is equal to Z times W totally bar. This means that Z is this number, W is this number. I multiply them first, and what I get, I conjugate it. But before doing the conjugation, I do the multiplication. So this becomes A times C plus ADI plus BCI plus BDI squared. But I squared is -1, so it becomes minus BD. And then bar. But then what I do, I write it in the standard form. So this is not A. This is A times C, sorry. So this becomes AC minus BD, the real part. And I factor an I out. That becomes imaginary part. But still, I have this bar left. So what's the answer? I have to keep the real part as it is for conjugation. But I have to change the sign of the imaginary part from positive to negative, negative to positive. So here I have to write negative. This is the answer that I get for the left-hand side. Yes? For the right-hand side, what should I do? Z bar times W bar. But Z bar is A plus B I bar multiplied by C plus DI bar. But A plus BI is what? Is A minus BI. And C plus DI bar is C minus DI. And then I start multiplying it again. So this becomes AC minus ADI minus BCI positive BD I squared. But I squared is -1, so it becomes again negative. And then I collect them, the real parts together. The imaginary parts, I have I in common, I have a negative sign in common, so I factor a negative sign and an I out. This becomes AD, this becomes BC. And this is comparable exactly with that one. So this is number 1, this is number 2. So I would say, therefore, from number 1 and number 2, I can conclude that the left-hand side is equal to the right-hand side. Yes? So, and then I really want you to do this one yourself. Okay? That's a little bit harder because the division is a little bit harder, but it will work. But of course, you can do it reasonably simpler. I don't want to actually solve it for you, but I want you to know that this is also correct. Okay, let me ask you one question. What about the powers? So what is your opinion about this? If I have z to the power of 4, for example, 5, anything, and then I want to bar it, do you think I can replace these operations? Instead of raising to power 4 first and then conjugate, can I conjugate first and then raise to power 4? The question is that, do you expect this to be true or not in general?
den här sidan ändras av. Så den här första min koll på första sidan var Z84. Z är ju bara över. Vänta, det är en bar över där. Ja. Jag såg inte den, okej. Men om det var utan bar, jag tror det här skulle vara om det bara över den change sign.
So first of all, what is your intuition? Yes or no?
No.
Yes or no? The answer is yes. Of course, the reason is that I have written this formula for 2 numbers here, but you can write this for 3 numbers, for 4 numbers. But of course you have to use mathematical induction to prove it for more than 2, yes? For example, if I tell you that if Z1, Z2 and Z3 are complex numbers, then it is not hard to understand that this is Z1 bar, Z2 bar, Z3 bar. Why? Because this product can be viewed as the product of 2 numbers. This is the first number, this is the second number. The first number becomes bar, multiplied by the bar of the second one. But this is now 2 numbers. According to the 2 numbers rule, I can write this bar, that bar, yes? So mathematical induction, exactly like that, you can prove it for any number of this. So then it means that if I want to understand this, what I can write that this one is nothing except Z, 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 and Z4. 4 times bar. But according to that rule, it becomes bar on the first one, it becomes bar on the second one, bar on the third one, bar on the fourth one. But then I am multiplying the same number, which is Z bar, 4 times. So this becomes Z bar to the power of 4. Yes? So remember that this formula is also valid if I have Zn bar, it can be written as Z bar to the n. It's also good to know. Any questions? Okay, now let me ask you one good question here. So can you tell me let me find it. Okay. Let me write it here. Everything we need is on the board. So, let Z be equal to this number, 2 plus 3i to the power of 100 plus 2 minus 3i to the power of 100. Yes? Determine the imaginary of Z. Okay, I want to wait a little bit for you. I have given you a complex number in a very symmetric form, but of course with very high power, and I'm asking you, can you reasonably, in a short amount of time, answer what is imaginary part of Z? Because in principle, you have to raise it to power 100, raise it to power 100, and collect the real parts and collect the imaginary parts, and that total imaginary part is the answer to this. And of course you understand this is not possible if you want to raise it to power 100. It's not practical. But can you find a shortcut for answering this question? So this is somehow related to what you have learned and what I have written on the board now. Can you find which formulas are suitable for answering this question? Okay, I want to give you a little bit of time to think about it yourself. Any progress? I think from pedagogical point of view, if it's good if I remind you about a similar problem. If you go back to your notes, I more or less asked you the same question, but instead of giving you this, I gave you this. Yes? I don't know, if you go back to notes or videos, you will see that at some point we solved the same problem, but instead of giving you this as Z, I gave you this as Z. Okay? From pedagogical point of view, it would be good if we see that why we have to change our strategy. why we couldn't follow the previous method. So let me just remind you of what we did here. I don't know, do you remember it or not? But I told you that for higher powers of complex numbers, we will study this systematically later. But for the higher powers of complex numbers, at this stage, it is reasonable to calculate some low powers to see if we can find a pattern or something. Yes? So for example, in this case, 1 plus I to the power of 2, I calculate, it becomes the first one to the 2, 2 times the first one, the second one to the 2. But because I squared is just -1, it becomes extremely simple because it becomes 2I. And then I want to have power of 100, so I raise both sides to power 50. When I raise to power 50, it becomes 1 plus I to the power of 100. If I raise these to power 50, it becomes 2 to the power of 50. And then I to power 50, I can calculate it as I to power 2 to the power of 25. Yes? Yeah. And then when this becomes -1, so it becomes -2 to the power of 50. So it becomes real. And then if I calculate the same thing for negative sign, the only difference is that here it becomes negative. Then this becomes -2I. And then when I raise it to power 50, this becomes -2 to the power of 50. But what happens? The same story will remain, yes? This becomes +2 to the power of 50. So this becomes positive this time. Yes? So for the positive sign, I get the negative value at the end. For the negative sign, I will get a positive value. The reason that I'm doing it a little bit quickly because I have already done this problem. And then, what is z then? Z is this number plus that number. The first number was this number. The second number was this number. When I add them, it becomes 0. And then you can immediately answer, what is the imaginary part of this number? Of course, both of them are 0 in this case, and including imaginary part. So you can answer this question. Why do you think that this method will not be, it is not good for this problem, even though they are very similar? The reason is because it was a coincidence that I had this cancellation here. If I want to do here the same thing, 2 to the power of 2 plus 3I to the power of 2, it becomes the first one squared, 2 times the first one times the second one, and the second one squared becomes -9. But 4 and -9 are not cancelled, so it becomes -5 to the power of 12I. So if I want to raise it to power 100, so of course I can raise to power 50, this becomes 100, but then this becomes 50, this becomes 50. Of course 50 is better than 100, but it is still too big. Because still I have a binomial. The reason that I could do it in this form, because it was a coincidence that they cancel out. Yes? So that I want you to understand why I am changing my strategy to solve the same problem, similar problem. So it's good to understand why you are doing it. Okay, so this is not working, at least not very practical. But how do you think, why do you think I gave this example before? It's clear because you could do it while I have given you this example now after talking about what I have talked about today. So there should be a reason. Could you discover the connection and help me to solve it? Yes? So every one of you immediately recognize this and that pattern. So what are they? They are conjugates. Okay? So we have to understand actually what is going on. Let me ask you, might be you ask yourself, how should I do that? How should I know I have to do it? But you have to have experience, of course. If you don't mind, let me calculate z bar. So these problems I consider hard because usually you are supposed to calculate this thing. But I am telling you, if you observe that these are conjugates, so might be it is not that hard to understand that I conjugate this one. Let us see what happens. So this means that it is 2 plus 3i to power 100 plus 2 minus 3i to power 100. Agree? Yes? I take the conjugate on top of it. But now, this was the hard part. The rest I expect you to be able to tell me what to do. What is the next step you think I will do? Tell me. Yes? Yes, I can see your hands. You will separate them, yes? So this is the sum of two numbers, and I want to conjugate it. According to the first rule, if I have the sum and then conjugate, it becomes equal if I conjugate and then sum, add. That's equal. So I just do that. I take this one and conjugate it, and I take this one and conjugate it, and then add them. Yes or no? Okay. But now, this one tells me, if I raise to power 100, then conjugate, it becomes equal to what? If I conjugate first, and then to power 100. Is that understandable? That's I am using this rule. The same thing will apply there. Agree? But this is now very easy, not hard. What's the answer? 2 minus 3i to power 100. What's the answer to this one then? 2 plus 3i to the power of 100. So what happened? I calculated z bar. I ended with this number. But what is this number? It's the same as z. But the only difference is that they have written in different order.
Yes.
Yes or no?
Yes.
So z bar is equal to z. Yes? So z bar is equal to z. I have written, but I cleaned that. So I ask you, what happens if z is equal to z bar? Do you remember I wrote a remark here by red color?
Yeah, is it there?
So I told you that z is equal to z bar if and only if what happens? Z is real. So this means that z is real. Agree? What value is that? I don't know. But I know it's real. And that is the reason they haven't asked you about the real part. They have asked you about the imaginary part. So what is the imaginary part of a real number? Is 0. Okay, so you see that there are actually, when I was talking about these things, they looked trivial. But if you use them in this problem, it's not that trivial. So these are the powers of knowing these as theorems rather than just merely problems. Okay, let me give you one more problem and then we finish. This is, I will call it this. This I think is you have to be creative to be able to solve this. Not hard. Algebra is not hard, but you have to find a way to do it. Okay. I am telling you this example. If a plus bi to the power of 5 is equal to c plus di, I would tell you that a, b, c, d are all real numbers. If this is the case, show that b plus ai to power 5 is equal to d plus ci. That's a very nice relation, yes? So I am telling you that if a plus bi to power 5 turns out to be c plus di, it's a very strange relation. If I change a and b here, the effect will be changing c and d here, which is not trivial at all. Yes? I want you to think about this. We have a little bit of time. We can think for 5 minutes and then I can solve it for 5 minutes. Let me give you a little bit of hint. So here, A is here, B is here. When you compare what happens, B becomes I-less, yes, without I. I-less. Yes. And A is multiplied by I. So what should we do here? If you think about, well, how can I do this so that B becomes without I, A picks up an I, then might be you can solve the problem.
Vi ska show this. What if I just want like...
So, how should we do that? Just think about this. I give you a complex number, A plus BI, and I want you to write it. I've already written this as a remark for you, but of course I cannot rely on your memories, I know, but after 3 years of teaching you, okay? But A plus BI, I want to have B without I, but the price that I want to pay is that somehow A includes I. Do you have any idea what to do? Okay, let me ask you the question. You want to get rid of I for B. What is the first thing comes to your mind? Yes? What did you say? Something? I think that was correct. Yeah? So you want to take it out. So what you do, you take I out. At least this will solve this part of my problem. It becomes without I. But then the bad point is that what happens to A? Tell me. It becomes what? A over I. But I told you that it's the famous relation that this is, what is this? That is always true for real numbers. But something particular for complex numbers, there is something more true. No, minus 1 is always true.
Oh, but
I told you that for complex number there is also something more. Minus I. Okay? So then what happens, this can be written in this form. I minus AI, and then we have B. Yes or no?
Yes.
But the problem is that now the sign has changed. I want to have a positive sign. But what can I do with positive? If I want to make it positive, I use double bars. Yes? So what I do, because I cannot change it, but I can write it as I can write it as B plus AI and then bar.
Yeah.
Understandable? So that was the trick. In this way, at least I have a good combination here. You see, I moved I by this trick to A, and by this trick I got rid of this minus sign that appears. Yes? Okay, so then what happens, this tells me that A plus BI to power 5 is equal to this expression to power 5. So this becomes A to power 5 and B plus AI bar to power 5. Agree? This is on the one hand. So let me simplify this. What is I5? Can I simplify I5 as much as possible? I5 is I2 to the power of 2 times I. But I2 is minus 1 to power 2 is 1 is just simply I. So this, I can clean this, okay? So this means that A plus BI to the power of 5 is I times B plus AI bar to the power of 5. Yes or no?
Yes.
Okay, but by the way, I can change these two. Yes or no? We just learned that if I bar first and raise to power, it doesn't matter if I raise to power 5 and then bar. I have to be careful that I is outside. Yes? But this is my calculation. This is my calculation. But this is given to me that this to power 5 is C plus DI. Yes? So then, instead of this expression, I can write C plus DI. Agree? And then it becomes I, B plus AI to the power of 5 bar. So you see, when I started this calculation, I even didn't look at here. I started this calculation up to here. So this calculation is independent of my assumption. Now this is the first time I am using my assumption. Instead of this, I put this one. Okay? Now still it is interesting. How can I reach to this one now? Can you help me? It's very close in spirit, you see. B plus AI to power 5. This is my problem here. But everything is more or less very nice and good. Can you tell me what to do?
Do bar again and then bar again.
Yes, I have to get rid of the bar.
Yeah, can you
What can I, how can I get, I can make a double bar, yes? This number is equal to that number, so C plus DI bar is equal to I times this combination, and then totally, and then there is a bar here, and then I put another bar here. You see, I took a bar here, but I have to take the bar from here as well, yes? But what is the bar here? Can you tell me? It becomes C minus DI. So you might think that I am troubled. Yes, I am, because I want the positive sign. But don't worry. This bar, can you help me to write it simpler? This is a product of two numbers, and I am taking bar of the product. So it becomes the first one bar multiplied by second one bar. But what is the second bar? The second bar is this one, and I bar it again. Okay? Yes or no? But what is I bar? What is I bar? Minus I. So this becomes C minus DI is minus I. But these double bar are cancelled. So this becomes B plus AI to power 5. So far so good, because I have this combination that I need. But unfortunately, I have this negative sign, but don't worry, I have something to compensate for that. I want to get rid of this minus I. How? How should I get rid of minus I? I can divide by minus I, or even better, I can multiply by I. Because if I multiply by I, it becomes negative I squared, but negative I squared is 1. So I multiply by I. If I multiply this by I, it becomes negative I squared, which is 1, and it becomes B plus AI to power 5. Then finally, I multiply I in. So then what happens? I multiplied by minus DI becomes minus DI squared, becomes positive DI, positive D, and then positive CI. So this is one of those interesting problems that you have to work with bars, eyes, and things like that to go from here to there. So we were able to do that. Okay, I hope that you have enjoyed the problem, yes? So it was very simple. Algebra was not complicated at all, but it's a very good place to teach you that they really are useful. Yes? When I was writing them down, might be you don't actually appreciate them, but now that we reached to this one, I really recommend you to go back and revise this calculation once more. If you don't understand, you can watch the video, otherwise you can come back to me and ask questions. No questions now? Okay, thank you very much.
Don't erase it.